in the data is literally like what you're teaching your model. And so no matter how good your model is, if like you haven't looked at your data in a while, it's very likely that you have like a bunch of garbage in there, like a bunch of, let's say, like log events that are test logs and they're just like, nobody bothered to filter them out because whatever. But then you remove those and you see huge performance gains. Or, recently I had a project where like literally just changing how we define like what label we use. In many ways, if you enjoy working with data, I find that like it could be just a very powerful thing to do because it's usually more informative about the actual business application. You kind of get to see like, oh, like, what is the outcome that we're trying to model, and you get a lot of performance gains usually.
Welcome to the Software Misadventures podcast, where we sit down with software and DevOps experts to hear their stories from the trenches about how software breaks in production. We are your hosts, Ronak, Austin, and Guang. We've seen firsthand how stressful it is when something breaks in production, but it's the best opportunity to learn about a system more deeply. When most of us started in this field, we didn't really know what to expect, and wish there were more resources on how veteran engineers overcame the daunting task of debugging complex systems. In these conversations, we discuss the principles and practical tips to build resilient software, as well as advice to grow as technical leaders.
Hello everyone, this is Guang. Our guest for this episode is Emmanuel Ameisen. Manu is a machine learning engineer at Stripe working on fraud prevention. And before Stripe, he led more than 100 ML projects at Insight, helping fellows from academia or engineering transition into ML, which is actually where I met Manu. It was super nice catching up with him and get his stories and pro tips on things like the common mistakes people make when starting a new ML project. What's similar and different about the lifecycle of ML systems compared to traditional software, and writing a book. Please enjoy this very educational and fun conversation with Emmanuel Ameisen. Hey Manu, it's great to have you with us today. Welcome to the show.
Hello. How's it going?
Good. So Manu, we met at Inside Data Science a couple years back, which is also how I met my co-hosts, Austin and Ronak. How did you end up at Insight?
I ended up at Insight initially as a fellow. I was a data scientist for a couple of years, and I got really interested in kind of like deep learning and newer approaches to ML. And so I joined Insight as a fellow because I was like, it'd be a really nice way to change jobs. And then I ended up liking Insight so much that instead of going towards an ML role, I stayed there for a couple of years.
Nice. So I guess for people that are not familiar with the Insight, like maybe a little bit about what does Insight do and what'd you do when you were there?
Yeah, so Insight is a professional education company. So the idea is you'll have people that either have PhDs or postdocs or that are engineers or that were data scientists like me that want to transition to mainly roles in data, so like data engineers and data scientists. And they'll come to Insight, and then it's a project-based learning approach. And so you do a project for about a month, and then you use that project as a portfolio piece to sort of like go to prospective employers and get interviews, and then transition into your new career. And so what I did there is I led the artificial intelligence program, which was initially it was a lot about kind of like deep learning research and, kind of trying to apply cutting edge research. And then it pivoted to being some of that and then a big focus on machine learning engineering, which was sort of like what many companies really needed at the time. And kind of there was no traditional path into, and it was a bit of a like hybrid role in between data science and like engineering. And so spent a couple years leading that program. Which was super fun, and ended up through that seeing over 100 different ML projects. A lot of those projects that we did were like in partnership with companies, so it was really fun to see just a vast array of companies doing ML and helping them out.
That's interesting, really interesting transition, because I imagine new reps were getting a lot of activities, and I think a lot of people in the field, talked about like modeling the more research aspect. Was it a kind of a difficult decision trying to switch more towards like, the ML, like the engineering aspect of it, like even during the program itself?
That's super interesting. Yeah, kind of for two reasons.
It's risky,
One,
right? Because it's sort of going against the trend.
So actually what was happening is that there was these, like, I remember very clearly this being sort of like two waves where kind of companies we were talking to got really excited about the sort of research that we'd see at NeurIPS, and they'd be like, oh, we need to hire people that know how to do this. We're going to integrate this in, every single part of our product is going to be great. And then kind of literally lagging by maybe like a year or two, you had like the rest of the internet, maybe like all of the Medium posts, and like everybody got really excited as well. But by the time that was happening, the companies we were talking to were saying like, well, like this is kind of great, but we actually have a bunch of researchers and they're producing this research, and it's really good research, but it's incredibly hard to do anything other than publish it. Like we've tried to integrate it, but the researchers, we've partnered them with software engineers, but getting them to work together to like speak the same language is actually really challenging because they have different backgrounds, and making project work is really challenging. So there was a huge need. I remember sitting down and saying like, wow, we've had 20 conversations in the past month with different companies saying the exact same thing, which is we actually are good on AI talent. We just need engineers. And so that side in one way was like became pretty clear. It was hard because it was a pivot. But the part that then was the hardest, I think, was that then that meant that we were misaligned with the hype cycle, where like as everybody was hearing about like, oh my God, AI, deep learning, we do all this stuff, it's gonna be great. They would apply to Insight, and then they'd come to the interview, they'd say like, well, what I really want to do is like this very specific like computer vision deep learning, and we would have just come off of like, again, 20 calls with companies that were like, we will never hire someone like this. We have too many of them, or not never, of course, but that wasn't their need. And so there was a bit of a mismatch. Like we were kind of a two-sided marketplace, and there was a bit of a mismatch between kind of like what roles people thought were out there and then what employers actually were looking for. And so that was maybe the trickiest part there was kind of like just getting the messaging out, to be honest. Like, here's what people are actually looking for. And so we did a lot of work around blog posts and putting white papers out and trying to explain like, actually, this is probably a promising career direction if you're interested in it.
Like, do you think that hype has settled now, or do you think that is still the case where like a lot of people who aren't in the field or in the weeds think, oh, look at this amazing research on AI and deep learning models. But actually, when you talk to the companies, they're like, oh, we need someone who does more on the engineering side with machine learning, but not so much on the research side. Do you think that hype has settled or that it has balanced out over time?
So hard to tell. I feel like I'm not the right person to ask, in a sense that anybody that works at a Silicon Valley tech company has such a biased view of like what actually is probably the real distribution of use cases.
Yeah.
But I would say that even here, which is like probably like pretty advanced compared to like the market, it feels like there's still, in my opinion, a bit too much hype, which is challenging because there's a lot of like really cool applications of genuinely new technologies. Like it's not like it's all hype. There's a lot of incredible like deep learning around computer vision, but also just really great advances around like NLP and language understanding, and kind of like big companies have shipped really cool things. But it still feels like if you ask, I feel like the like average graduate in that field to tell you like which proportion of jobs are actually doing that sort of like cutting edge modeling, I think they would almost certainly like overestimate it still. At least that's my bet.
Yeah, I think I would agree with you there based on what I've seen. But again, I am also not the right person to ask.
It's getting better though. There was a time where it was genuinely like 100% of people wanted to train deep learning models, and that was 2% of jobs, and that was really hard.
Yeah.
So Manu, you actually led the session that I participated in back in 2018, 2019. But so what impressed me was sort of how diverse the backgrounds of the people that were in my cohort. So some were more academic; they come from CS or like PhDs in physics. But then you also have people that are software engineers that want to get more into ML. So I'm going to lead with a very bad question, but I wanted to get your thoughts around this, which is to say that would it be easier for software engineers to pick up ML skills, or would it be easier for like, AI sort of research or like for PhDs to pick up like software skills?
I mean, I feel like it's actually a really good question, because I feel like at least it's a question that comes up really often. And it was definitely something that we asked ourselves. at a program that tries to recruit people so that they can then be hired by companies. We're like, kind of which kind of backgrounds would be the most successful, which is a natural question to ask. Initially, I had the impression that it was easier for people coming from an experimental background to learn the engineering skills. And that's sort of because, for a lot of the ML work, the experimental side is more of a mindset, and it can sometimes be harder to teach a mindset than it is to teach tools. Right. Where it's like the mindset is like you formulate a hypothesis, and then you say, okay, my hypothesis is this, and then I'm going to test it out, and then you design carefully an experiment, and you run your experiment, and then you analyze the results very carefully, and you say, okay, based on the results, this is my next step. That's sort of like a thing that you can do sometimes in engineering, but engineering is much more deterministic, where like you make like a concrete design and then you implement it. And like you take a person like this and you teach them Python, and they can kind of do a good job. I think as the field has progressed, that my opinion has changed quite a bit actually, because like as ML gets deployed in production, a lot more of the scope of what people end up doing is everything around ML. There was like a paper by Google around ML systems, and in that paper they have a graph, and it's like ML systems, and there's I think like I don't know, like maybe 25 boxes that represent like monitoring and like training and whatever, and there's like one very very small box that's like training a good model, and that's that's probably like, I think if you've worked in that domain, you've seen that like that's a small portion of the task, and so even if you're like a really good engineer, and maybe it'll take you longer to get that mindset, it's certainly possible to learn it. It'll take you longer to get the experimentation mindset. There's so much useful work for like engineers that are interested in ML that strategically it might be an easier learning path, where it's like you'll find a role, you'll get on a team, and then you'll just like kind of like learn by osmosis. And so I feel like nowadays it might have flipped where it's easier for engineers. But of course, there's no hard and fast rules. It's kind of anybody can do it if they're motivated enough. But it's changed, I think.
Nice. And so I remember when I was trying to kind of start my ML project, it's very much, I'm trying to, I think it's almost kind of like a startup. You're trying to build a product, you're trying to show it to potential companies at the end to kind of pique their interest. And so maybe, it's not exactly customers buying a product, but still you want to have something that's sort of cool, that's shiny, but that also hopefully add value, right? So that people, see. But like, this show is about misadventures, and I'm kind of curious, what are some of the common mistakes that people make when they kind of go about starting their like ML project?
Yeah, I was trying to think about this ahead of chatting with you both. I think there's a few, and I've given up on trying to categorize them all. But I think a really common one that used to happen all the time at Insight, that kind of happens everywhere, and like I've definitely done it as well, is that the fun part of machine learning, or one of the fun parts, can be like you have your data set, you have your training data, you have your test data, and then like you're just trying your models, you're building new features, and you have like this number, which is like maybe your accuracy or your loss or whatever. Like there's a number you care about that's your performance metric, and you're at the casino, you're playing slot machines. You're like, all right, I'm going to try this. Oh, 0.82. All right. Oh, let me try this. Oh, 0.85. Okay, great. And you just keep going and you do your thing. And like, it truly sometimes I feel was like a gambling addiction, where like you'd see fellows and they'd say like, well, I haven't really figured out, what my product is, or if it's useful, or if anybody cares about it, or really even like any of the flow around like what this would be. But I found like a data set of 1 million text documents, and like my accuracy is like 0.99, and I spent like the last 7 days on it. And you'd be like, but why? What are you trying to do? You'd be like, I don't really know. But like, look at this score. It is it is peaked. Like I've solved machine learning. And I think that was like, and is still one of the biggest challenges of ML, is like when you start, oftentimes you have to have this kind of like delicate dance where you go between like, what are we trying to do? Like if you're trying to like, I don't know, like predict something new that you're going to show to users, you probably want to say like, okay, well, if we're going to predict this new category, like how accurate do we need to be? Okay, we need to be this accurate. Let's try, and then you fail at your first try, and then you like maybe change the product a little bit and go back and forth and have this little dance. But like the biggest failure mode is like you give a data scientist a data set, they are, they're gone for a week, and they'll come back with like a really high number that is usually absolutely useless. And I think that was one of the most like common things that we have to like bring back people from the edge, like hey, like get away from the laptop, like you don't need one more training run, just like let's take a step back and think about this for a second.
Going deeper on that, like, what was it like? Was it usually, maybe if you think about it as a product, you don't actually need that sort of level of performance, or is it just plainly wrong? Like, the test set is polluted, or there. How do you go about convincing the fellows? Hey, even though you spend 7 days on this, but you should look at this other thing that's probably would do more important things for your project.
Yeah, I mean, it can come in a variety of flavors. I'll give you like a kind of example that happened multiple times. Is like, so we would do consulting projects for companies, and the idea is like they'd come with a problem, and they'd like present it to the fellow, and the fellow would help out. And like a common shape of that would be a company comes in and says like, well, we've done this model for this thing, and we've gotten 80% whatever precision. We'd love it if like your fellow could like get that number up. And multiple times, it's like the fellow would like do some work and like get the number to like 99%, like almost immediately, like in a couple days. And they'd be like, oh, like, have I solved it? Am I done with this project? And multiple times, as you alluded to, like we looked at the test set, and I remember one case where it was like predicting some sort of outcome from patient data, and it's like the same patients were in the training set and the test set. Right. And so if you just and the patient ID was a feature, and so if you just use the patient ID, like you get 100%. And in fact, it was kind of surprising that the company didn't have 100% initially. I don't really know what they were doing, but like you have like more subtle ways of that. Like it doesn't have to be patient ID, but you can have like data leakage. And so if you don't ask yourself like, is this too good to be true? Like, why is this performing so well? You'll just like. Your model is essentially, even though it's got 100%, is useless. Like if you were to ship it in a medical device, it'd be like a dangerous and bad thing to do. And so it's worth thinking about it. That's one. But to go back to your question, like another common failure mode I would say is, like let's say you're trying to build for a search, like you're trying to build some like search model where I type a query, and you help me, with what my query is going to be, and you do like Google autocomplete. One approach is like you literally try to guess the sequence of characters that I'm going to output. And you can do that. And in fact, I think like at some point it makes sense to do that, but it's pretty hard. There's like a wide space of what I could write. But, you could spend weeks and weeks like just iterating on the sequence to sequence model, or like some complex models like predict the sequence of characters. Whereas in fact, maybe you could take a much simpler approach where instead like I start typing my characters, and you just suggest like one of 5 categories. Like maybe you're searching about like books, maybe it's about mattresses, and like that is much easier, and that's something you could do in a couple of days. But it might be 90% as useful. And so sometimes it's just about kind of like thinking back and saying like, my first results were bad. Could I change the product so that I change the modeling approach so that it's much easier? And that's I think like a very common failure mode where you think way too many times on the machine learning, whereas you could like save yourself a lot of time by changing your product slightly.
I think these like learnings from leading these projects, I think is really cool, because I feel they proxy a lot of times where big companies, right, they want to leverage ML, and it's usually, someone maybe from the product side, right, that are like, hey, is this like something that we can do to make our product better? So then, you get like someone that's sort of new either to the data set or to like the sort of the deployment environment, and then trying to kind of build this thing out end to end. And I'm kind of curious, like, do you have any sort of tips or how you think about like how to help like non-ML people that want to use ML to be more effective, I think, in terms of like what they should expect, right? Because a lot of times maybe, some of the, I think the sanity checks that you mentioned are very much like, hey, let's, make sure that this thing, maybe we can solve it by rules first before we actually try ML. But I wanted to get your thoughts around that.
Yeah. I mean, that was one of the patterns that we kept seeing, that like companies would invest, in a lot of ML engineers and data scientists, and struggle to reap the rewards. I think the rules that you talked about is a big one, where you kind of want to call out ideas that there's a machine learning and there's magic, and some projects don't need machine learning, they need magic. And it can be sort of like, well, what I'd really like is, if one of you goes to my website, I just kind of like automatically know like what kind of devices you like and everything about you, and I automatically just like show you a page, and then I automatically know how much money you have, and I can like give you the exact price that is like will give me as much money, but also you are 100% likely to buy it, and that's just not going to happen. That's something that maybe over like years and years and years you'll get to like an incremental system that like something like this, but it's just not possible. And so I think rules, or at least like writing out a set of heuristics, is a very good first step for anyone that doesn't even know ML. For the vast majority of ML systems, you can at least get like something off the ground with rules. This is not always true. There's some things with like kind of like advanced computer vision where maybe that's less true. But for many, like at least concrete problems, which are usually on like, tabular data, certainly things like some of the things that we do at sort of like fraud detection, or like predicting clicks, predicting like recommending videos, you can get pretty far with like heuristics of like, well, if you've liked 10 videos in this category, maybe we give you another one. And that doesn't mean that you have to necessarily build that system first, but it can be a good heuristic to know whether you're asking for too much of your ML system. Like if you can't express it that way, it might be that you just want something magic. I think that's the first thing is scoping well. I think the second, like the only other pattern I've seen is just that iteration speed is really the key. It's like the projects that are the riskiest are the ones where you want to build the world, and and you have this kind of like holistic, here's everything that we need in order to like fully solve this problem, and that's usually challenging because at the point where you're doing your first ML solution, you don't have enough information about your product or like what you're trying to do to make the like correct design decision. Usually what you want, again, it's like an experimental mindset of like, oh, we think that we think that people will like this new feature where we recommend videos on YouTube. Like we think this will be nice. Let's just like try to throw something there and see what the uptake of it is like. And then once you've thrown like your very simple model, it's taking you a couple of weeks, then you can iterate really fast. And that usually works well because if it was a bad idea, you find out in a couple of weeks, as opposed to, doing like a 9-month project that then fails and then kind of like scares people away from ML.
I see. Speaking of iterating fast, the Insight project sort of is very fast, right? Like 4 or 5 weeks, you gotta get something up. And I feel like I will be doing myself a disservice if I don't ask you what was the most hilarious misadventure that you've seen when you were leading these projects. And you can't use mine, obviously. That would be, unprofessional. So.
All right. Well, I only had one example. So. I think, like, listen, I don't want to pick on anyone in particular, but I do think that there's like the kind of funniest ones to me at least, where again, like Insight's motto was iterate fast, start with something simple, and sometimes fellows decided to not do that, and they take let's say a classification problem, like where they would like a common one was classifying support requests. Like somebody writes in as a ticket and they say they have a problem and you want to efficiently route it to say like, is this about, I don't know if it was like an ISP, like a connection, or is this about like billing? Is this about something else? And they would start and say, all right, well, first thing I'm going to do is I'm going to start with Bert. And they do something like super complicated and they get their pipeline and they're like, boom, Bert, like 85% accuracy. And then usually the feedback we'd give them is like, it's great, like happy you got it. But in order to kind of contextualize this for someone, you probably want to just compare it to like a simple like baseline or like some simple thing you do yourself.
Quick thing for our listeners. Can you just explain quickly, BERT? What is it?
Oh, BERT is like an advanced natural language processing model where essentially it was pre-trained by Google on a very, very large corpus of data. And it performs really well when you take this very large model and kind of fine tune it on your data set, usually get some pretty good results pretty fast. But it is still pretty heavy and pretty unwieldy, and at least as of this podcast, usually not the fastest thing that you could do, but that might change. But so they'd start with this kind of like advanced method and also like pretty heavy duty method. And then you said like, all right, well, do you want to try like a baseline? Maybe you could try some simple machine learning model, or maybe like you could just write, like a if else, like a switch of a function, and just say like, well, how would you do it? And then they would get 95% and like just like blow their very complicated model out of the water. And like,
Nice.
I mean, that's really a brutal situation to be in, because then you're like, well, I guess like either you have to lie about how you got to this result and say like, no, I started with a simple model, and then I tried something complicated, but it didn't work out. But like, it's really not a good look if you're like this person that's like, well, I like used this like massive weapon, and then I realized that like a fly swatter would have been enough. Those kind of mistakes were usually like pretty brutal and honestly pretty disheartening to see. Like, I think it's also demoralizing because you're kind of like, oh, why did I do this? So that's why we insisted on that so much, is that we'd seen that pattern really a lot of times.
It's interesting that, like from at Insight, for instance, when fellows go through this process, it's unfortunate and, as you mentioned, disheartening. But again, the cost is not that high. Like in many cases, they could, change the project or pivot or do something else. Do you think it's also applicable to many teams and companies who are trying to do this, where at least for someone who doesn't work on machine learning, I don't think about machine learning as a solution to a problem that I want to solve for. So I'm like, how can I do it brute force or like through rules, for instance, or like the switch cases? That's what I think about. But do you feel like sometimes teams fall into this trap as well, where they use machine learning to solve a problem where it's not the best solution or it's not the best tool to solve that problem? And like, if that happens, like, how could one go about figuring out whether ML is the right approach for something, or whether for something you just need something much simplistic that satisfies the spec?
Yeah, I mean, I think if you manage to write a flowchart that solves that, you'll make millions, because I think that's a really hard problem. There's a paper, again, I think it's by Google, that I think it's titled, if I remember correctly, machine learning, the high interest credit card of technical debt.
Oh, I think I've seen. Yeah, I've read that. It's a very catchy title.
It's an interesting one.
It's a catchy title, and it's an excellent paper, because like machine learning systems, the issue with them is like they can be super valuable again. Like I don't think we need to make that argument here, but like ML systems that are deployed sometimes can like make or break a company, or certainly make millions and millions of dollars, and usually a good ML system will outperform, like rules or switch case or heuristics, like almost always. But there's like a huge upfront cost to getting it right, or oftentimes a large upfront cost, and then like a large cost of maintenance, which we can get into after. But like keeping your models running well and behaving well is really hard. And I guess you just had a previous podcast episode about that, so all about it. But I think that the like heuristic, in a sense of, I guess, like heuristic for you, a person, to know whether machine learning is a good idea, whether you should do rules, is kind of like, it depends a lot on your company environment. Initially, there's some companies where you have infrastructure teams and machine learning platform teams that expose to you really nice primitives, when you can say, oh, like we already have this feature store where we have a bunch of features I can use, like various attributes that I can use for a model, and then I can just kind of like even maybe like have a UI where I can click and like train this model, and I can see if it's good, and it doesn't cost me anything to deploy it, and and maybe I can have like some data scientists look at it and tell me if I missed something, but it's pretty self-serve. I think that's the dream, and some companies are there, and that's, if you're there, then like I actually like would encourage in those companies. I think the success stories we hear is like everybody can just kind of like experiment, and then most people have at least a few good ideas, and so it's great. That's what you want. If that's not the case, then I think you want to be basically like do an ROI calculation of like, for teams that currently have models in production, how much time does it take them? Like how long on their roadmap? Like how much of it is just keep our model alive, or refresh our model, and how much is that in terms of salary costs? And is your application worth at least that many dollars? I think would be the number one thing. And And if the answer is like there's no team at the company that has ML models in production, then like you should almost certainly not do it if you're not like an ML engineer or like or somebody that has experience with it. So I think it depends a lot on the company.
No, that's a really good answer. I mean, that's really good advice for people thinking about machine learning in general and thinking of those trade-offs and costs because, well, it's not free for sure. It takes, and I definitely want to get into that life cycle of machine learning models in general. Like once you deploy it, how do you keep it alive, for instance? But before I jump there, I want to ask you this. So you were at Insight, you saw a lot of teams or machine learning teams structured in many different ways who also worked in many different ways. And then you have been at Stripe for a little over a year now, I think.
Almost 2 now, a year and 9 months.
Almost 2 years. So what made you choose Stripe? And can you talk a little bit about the team you're on and what you do?
Yeah, for sure. So I mean, I guess first of all, before I say why I chose Stripe, it's like why I left Insight is also because so at Insight I was leading these projects and it was super fun, and I got really to see the world of ML, and I'm extremely thankful for it because it's very rare that you can be in a role where like you're at the same time working on like helping an NLP project and then like trying to do like a cutting edge like reinforcement learning, like research thing, and then you're also doing production like ML engineer for companies. It was super fun, but I missed being an IC myself. And so after Insight, I really wanted to get back to doing machine learning myself because I really missed it. And so then I looked at various companies, and I think I don't know how much of that we should get into like in this conversation, but there's a lot of different ways to structure ML companies and to have different employees on an ML team like have different roles, and how you do that partnership can that's a whole realm in and of itself, and I think Stripe does that pretty well. But one of the main reasons that attracted me to Stripe is that I felt like one of the biggest challenges of ML is actually, I mean, the 0 to 1 aspect we talked about, there's many failure modes, but it's actually the sort of like, oh, you've built a model and now it's serving, millions, billions of users, like however many, like now it's popular, now it's used, like now what? Like, do you just keep that model there forever? How do you know if it starts doing something horribly wrong? Like there's so many like examples of models, for example, exhibiting bias, right, in search results. Like, how do you even detect that ahead of time? How would you be aware of it? If you retrain your model and it kind of like looked better on your test set, and your number went up, like, should you ship it? How do you know? Like that aspect of sort of like the engineering around ML, of sort of like it's almost, I mean, people call it ML ops, but it's almost just like quality assurance for models, right? Where it's like
ML ops sounds definitely much better.
I know, but it's good branding, I guess. That's why I wasn't in charge of coming up with the name. But yeah, like that, I don't know. Like, to me, it actually sounded way more fascinating, and maybe because I had been a lot in the 0 to 1 world, but I really wanted to like go at a company like Stripe, which sort of like has like a really good engineering reputation and like really strong engineers, and is like at a crucial point in like our customers, our merchants' workflows, right? It's like, it's not like we're this tool that like if we break, whatever, we'll see what happens. It's like Stripe processes their payments, and so it's an extremely sort of like high bar if you're going to have. I work on the fraud team at Stripe, and so the models I ship are the ones that decide whether a payment is fraudulent or not, and hence blocks it or not. And so, that's kind of a very compelling reason, let's say, to get that right, and to make that like a really important part of your workflow. And so, I was just fascinated with that, and wanted to both learn more about it at a company that, has seen like immense growth and has like a really good engineering reputation, and try to contribute, because it, like when I was looking around for resources, there wasn't much. It's not something that seems figured out. And so it was attractive for that reason.
I see. That makes sense. I mean, I think the fraud team that you mentioned, it's like the cost of getting a model or an incorrect model deployed in production is extremely high in that case. So the engineering rigor you need around quality assurance is much needed. So talking about that, so you've touched a little on that exploration phase or going from 0 to 1. Can you touch on the life cycle of a machine learning model once it's deployed in production? Like when I think about a software, or when I think about a web application, for instance, that is doing, let's just say, serving cat videos, in my head, I can think about, okay, this is how you would go about running it in production, keeping it alive. This is how the storage would look like, and like everything that goes into running it in production. For some of the aspects that you mentioned, like let's just figure out, once you train a model, how do you decide that this should be deployed in production? Like, let's just start there, and then we can build on top of that.
Yeah. I mean, it should be easy, right? If it's better, you deploy it.
Or rather, what I meant to ask is, how do you know if it's better? When you train a model and there is one running in production, how do you know the one you just trained is better than that one? Like, how do you validate that?
Yeah. Just to be clear, I said it should be easy. It is definitely not. So
I got the sarcasm. Ron is not paying attention.
No, for people not in machine learning. I'll play that hack.
Yeah, there you go. No, it's a good question because it's hard. I think there's a few things. So I guess like the easy part is all the way at the start, where you have your model in production, and hopefully you can use it to score some set of transactions offline. Let's say for Stripe, because we're talking about fraud, or you score offline and you score the same data set with your new model, and then you have some performance metrics like. For again, fraud Stripe, it might be like how many fraudulent transactions do we catch while maintaining the same level of false positives, and you say, oh well, it's higher, so it's better. But then like what usually happens, and this kind of like multiplies if your use case is more complicated, if your user base is more diverse, is that you have the like top line performance metric, and that's good. But that does not tell you whether a model is good enough to deploy for a few reasons. One example is, let's say I train this new model, and it does catch more fraud than the old model, and it doesn't have many more false positives in aggregate. It's the same level, but it turns out that I've blocked. Here, I'll use France as an example because I'm French. I've blocked every person in France. And somehow like I've lowered the block rate in every other country. So like in aggregate, you don't see it. But I've just blocked all of France, and yet the model performs better in aggregate. So like if you were just looking at the aggregate metric, you would ship it. And so I think like usually what like the terminology is here is like you'll have guardrail metrics where there's a set of kind of constraints that you want to be true about your new model before you release it. And so for like a search engine, you might also have sort of bias guardrails where you're like trying to make sure that maybe your new model is better at like improving the click-through rate of people click on the results more often, but also it doesn't start being super biased, or like when you type like something it promotes suggestive content that it should not, or that sort of stuff. What's really hard about those is that the set of potential things that could go wrong is almost infinite. It's like writing sort of all of those, right? It's like, oh, well, it doesn't block all of France. Also, it doesn't happen to block, everybody that's like over 25 or whatever. Like there are about like an infinite ways that it could fail. And so you kind of just have to think of a representative sample of them and then carry on. And so, sorry, go ahead.
And I feel like for that, a lot of times, and I feel like that's what I find interesting about ML, is that it does require a deep partnership with the product, because right, like how do you go about like doing those slices? A lot of times it's very specific to the domain that you're in, right? Like maybe age, geographic information, that's pretty general. But once you go deeper into like what kind of transaction it is, I think, right, like that. Has that been your experience? Actually, sorry, maybe go ahead with your original thought, but.
No, 100%. Yeah, and I'll even like there's even one more, which is that once you start adding enough metrics, just through laws of statistics alone, for every model that you want to release, it'll be worse on at least a couple of those.
Right.
And then like you have to have a product conversation of like, okay, well, if this model is better for everyone, but people that happen to live in Sunnyvale get results that are like 1% worse, are we okay with that? And like usually you'll have sort of like these criteria. We'll say, well, this is how much worse it can be for like one of the slices we care about, because we trust that sort of like over multiple model releases, like the same. It's sort of like we won't pick the same card multiple times, and so on average it'll be better for everyone. But yeah, you 100% need to have that product conversation and like to define which slices you care about, because the failure mode of not having any of those guardrail metrics or of having everything as a guardrail metric are both bad. And
right.
In one case in both cases you'll end up in a pretty bad situation.
Does it happen in cases where like you're having this conversation with product and some of the metrics, like you mentioned, which the model doesn't perform well on, like that becomes a blocker of sorts to roll out that model? So like when that happens, how do you go about figuring out, okay, we should retrain this model or do something else to move forward? Like how does one go about that?
Yeah. I mean, that's so fun, because there's no way, that doesn't exist to my knowledge. So I'll say more. You're not stuck. But like, okay, so let's say, you have one of those guardrail metrics and it's like, yeah, we end up blocking 50% of France. And we're like, all right, well, let's try to not do that. And the question is like, well, how do you do that? So one, you've done the first step of like measuring it. So that's good. So you can either have like, it's that broken out in your test metrics, or you can have explicit tests. There's more and more test libraries, which is kind of cool, that like say like for this model, here's like a couple examples, and like there's like, let's say like France is a country of origin, and like let's verify that it doesn't just like block them. But so you've detected it, and the question that you're asking is like, how do you fix it? And there's not really like a super easy way to give an ML model a human preference. Saying like, hey, you're doing great. There's just this one area where you're being really silly, and we'd love for you to not do that.
Yeah.
And like the way that you do it is very experimental, where you'll say like, okay, what we're going to do, for example, like a common technique is we're going to take all of the examples that are from France in our data set, and we're going to either like upweigh them, which essentially tells the model they're really important, or literally duplicate them. Literally say like, all right, well, we're going to, instead of like, we're sampling, like one person from each country, but for France, it's going to be 50. And then we're going to train our model, and we're just going to measure whether it's still as good, in general, and whether it stops being silly for France. The other alternative, of course, is that you could say like, well, for people from France, we'll just overrule the model and say like, no, they're good. But that is kind of a road that is extremely dangerous, because you do this for one model release, and then you release your new model, and you're like, oh, now it's people that are like 18 or under, and then before you know it, you just have like a horrible if else, and it's terrible. Like
going back to the switch statements all over the place.
Switch case, yep.
That's right.
That's I feel like see that at work as well, where. Right, it's like if you want to actually change something, right, there's two places. Either you change the model or you change the data. And a lot of times it's easier to change the data, especially if your model is more complicated, right? Like if it's neural nets, it's almost like, it's going to be much, much harder. But if it's really simple, logical regression, or maybe even it's rules, then, you can just like tack that on. Has that been the case for you as well? Just easier to fiddle stuff on the data side?
Yeah, I think easier is right? Because you could argue, and I'm sure like might have people in the comments that would, right? That you could say like you could change your model objective so that like you have an additional term that says, oh, and if like like a term could be, it doesn't have to be about France. If your concern is like a certain country is getting impacted, you could say like, we're going to measure accuracy, but also we're going to have a regularization, let's just like say like an additional term that lowers the model's performance score if there's a difference in performance between countries. And I would say that like there's really interesting papers in that direction and like some applications, but it's definitely harder currently to get that right. I think that might not always be true. It might actually, I'm pretty bullish on the idea that in the future, hopefully near future, that will be more of a thing that you can just kind of specify your concerns. But for now, playing with the data is definitely the easiest way to do that. But it definitely feels unsatisfying as well, right? It feels very hacky.
On one hand, if you're like fixing the model, you're like, ooh, I'm a proper scientist. Versus if you're just fixing the data, it's like, oh man, this is literally QA. But yeah, which is very important.
At the same time, and I was gonna say, like, at the same time, I don't know, it is a data scientist, like that. It's not a model scientist, and so like there's a reason why that is, and it's because it's very much like garbage in, garbage out. And I found in my career, at Insight, before Insight as at Stripe, that you can get very large gains from just looking at the data, and it kind of makes sense because like your model is in many ways a black box that optimizes for a thing, and you tell it like this is the input, just like get the output right. And that's great. And you can improve that black box so like it runs slightly better. Like you make the engine of your car better. That's great. But in the data is literally like what you're teaching your model. And so no matter how good your model is, if like you haven't looked at your data in a while, it's very likely that you have like a bunch of garbage in there, like a bunch of, let's say, like log events that are test logs, and they're just like, nobody bothered to filter them out because whatever. But then you remove those, and you see huge performance gains. Or, recently I had a project where like literally just changing how we define like what label we use for a given transaction also give like very large gains. And it's sort of like, in many ways, if you enjoy working with data, I find that like it could be just a very powerful thing to do, because it's usually more informative about the actual business application. You kind of get to see like, oh, like, what is the outcome that we're trying to model? And you get a lot of performance gains usually.
And I really love that quote. You're a data scientist, not a model scientist. I think that's very, very well said.
So one thing there are a couple of things which I want to dig into in what you said. One aspect of the validation itself. So if I'm thinking about a new version of a software, one way to validate whether it's performing well or not is, and again, this doesn't have machine learning model in it. It's just a website where we're releasing a new version. One common way to validate is do dark canaries, for instance, where you have one instance of your app on a new version that's taking traffic but not responding back, and you have logs and metrics to capture whether it's performing as well as the old one or not, or well, likely you want it to perform better. You're also looking for performance regressions and things like that. This requires a lot of infrastructure to exist, to validate. I assume, or I'm curious actually, what kind of infrastructure does one need to do this on the ML side? So like you have this model in production, you want to validate, like, does a team capture all traffic, replay it through tests? Do you have live testing going on? Like, what are some of the things that teams do to get this signal early in the process?
Yeah. You call this dark canary, is that what you said?
Yeah, dark canary, which is you have a version of a product, just one instance or a few instances. They're just not responding back. They're just taking traffic.
Yeah. No, it's funny because there's a very similar, I imagine a very stolen idea in ML, which is the same thing. But usually I've seen it called Shadow, which is amusing to me because it feels like a slightly nerdier, more World of Warcraft version of it.
It is a better term. I agree. Yes.
Yeah. But yeah, so you could do that. But before we get there, okay, so I would say that, the first way that you do it again is like, hopefully, when your production model is scoring, you're kind of like logging both its scores and the values of the features and like anything that you could log. Because then what you can do is that you have those logs, and when you train a new model, you can say, cool, let's take the logs of the last 3 days, we haven't trained on that, and let's evaluate and see how the model does. And that gives you sort of like an early estimate of performance. It's pretty good, but there's a bunch of things that can go wrong, especially if like your model is using new features and you have to redefine them. You can kind of like leak data from the future. There also could be like just like some differences between your online and offline scoring system that can like make that an imperfect evaluation. So you would do exactly what you said, which is you would do Shadow, where you basically send every request, you fork it, you send it to like your main sort of code path, that usually also has like a sort of like tighter SLA, and then you also duplicate it and you send it to Shadow, and Shadow scores it, and you log that somewhere, and at the end of the day you compare production and Shadow, and you say, okay, this is how they stack up. And that's a pretty common pattern, and in fact I'm a huge proponent of it. I think that like a lot of machine learning is about data, as we mentioned, and getting consistency between like this, like the first like log system I talked about, being that like making that represent online data is so hard, and it is like very hard to get right. And so it's much easier, especially if you like don't have that many resources, to just build the like infra to do Shadow, which I would actually argue, like at least in the case of machine learning, isn't that much, because you literally just need another server that can expose an endpoint, and that just like hosts your model, and like you just log. And like that is a great way to measure model performance. And so I think, I don't know, I actually, only remember that you mentioned that there was a similar process in normal engineering. I don't remember what your question was, but I'm a fan of Shadow.
That's a great answer. I think I remember reading a post about it, and I got very inspired, and I was trying to figure out how to do it. And then I think the setup at our place is a little bit trickier. But I remember like, oh crap, I gotta set this up, and then have to connect this to this. And I was like, all right, maybe let's wait let's wait a quarter or two. So for you guys, is that something that you guys maintain yourselves in terms of that entire sort of shadow mode infrastructure, or is there like a different like infra team that or tooling team that helps?
There's so we have an ML platform team that builds great tooling, and part of the tooling that they build is sort of like this infrastructure to call models, and so that's something that we can leverage, and then we can sort of like have our main production model, and then have another model in Shadow, and it's for us it's not much work on our end, which is really nice. So yeah, it's a lucky position to be in for sure.
Nice.
Nice. The other aspect of running machine learning models in production is also like when something goes wrong, you want to be able to debug it. And again, if I'm comparing it to software, it's like, well, attach a debugger to it, worst case, and see what it is doing. How do you do that with a machine learning model? Like, what are some of the techniques that help debug a model in production?
Oh man, well, yeah, because I was going to say it's already hard when it's not in production, right? So if you give a data scientist a model, I mean, to take our previous examples, right? If you give a data scientist a model and you tell them like, well, this model somehow has learned that all French people are fraudsters. Like, why? Like I've looked at the data and like it doesn't seem clear that that's a pattern. And machine learning is not magic. So if your model's learned that, there's something in your data set that like leads to that behavior, and maybe some set of correlations, or it could just be honestly a data issue, right? Maybe like you just like somehow forgot to fill in that column and it just got misinterpreted. But there's no easy path from an observation, from a sort of like high-level observation of what your model is doing, to a resolution other than inspecting the data. Again, you can often look at, in some models, you can look at like the model itself. There's some explainability to it, but it's rare that it'll answer questions as nuanced as this one. Usually explainability will give you, let's say, globally, this feature is important, like country is important, which is good, but it's not exactly what you're looking for. There's some methods for local explainability, but they also come with like a bunch of caveats and like it's not debugging. I guess is what I'm saying. It's a separate problem, right? Because like when you say debugging, you're saying like there's a problem. I know this is wrong. Fix it. Whereas explainability is a lot of like, this model is doing something really weird, interesting. Let's study it for a while, which is not at all what you want when your model is breaking in production. Mm-hmm. I think that there's it's such an interesting question. The way I look at it is that it's mostly about monitoring. And even that is hard, where it's like your model, how do I say this? Oh, so I guess I'll give an example from Stripe, which is, we have a model that tells us whether transactions look, again, fraudulent or legitimate. And so, that model, it scores a bunch of transactions. And then the question is like, well, how would you know if that model is sort of like performing poorly, due to anything, like maybe some data pipeline breaks and it's not getting the correct features anymore? And the answer is it's really hard, because while you can tell that at a certain point in time, the model is doing something it shouldn't do, like if you compare it to another model, when you're in production, like how do you tell the difference between our model is broken and, one merchant that's using Stripe just opened up in a new country that just happens to have an extremely high fraud rate. Like it'll probably look very similar for that merchant. Like there's a bunch of like new fraud, and you're like, oh, this is really weird. Like, we should alert on this. But your model is kind of doing the right thing. And so I think like before you get to even debugging, getting alerting right is really hard. And it's something where like most alerting systems and monitoring systems I've had like struggle really hard to not have too many false positives, because just trends are crazy and defining what's normal is hard. I guess I've been speaking for a while, but one idea there that I find promising, that I haven't battle tested as much as I want, but that I think is interesting, is like you can try to compare your current model like in production to your model in shadow, and do that not just like as you're trying to deploy a new model and saying it's good. You could try to do that and say like, are these models reacting similarly? And if like one model is going crazy but not the other one, then maybe you should alert on that. But then as far as debugging it, then you still have the problem like, well, what do you do about it? Usually you roll back.
No, it's interesting because there's like the sort of the data coming in that could be the issue, right, as you described, and then you could also be the model itself. So then how do you sort of distinguish the two? Because the data coming in is maybe almost like I guess both are kind of like an A/B testing thing where you also need to kind of set up sort of time frame, right? Because as you said, it's not a point in time. Like you actually need to worry about sort of like what are just statistic outliers versus what's actually it being broken.
Yeah,
but
exactly.
You mentioned alerting. So do you also take care of alerting when you deploy a model? Like, is it, I know different teams or ML teams at different companies are structured differently, but at Stripe for your team, like, let's say you did all of the validation that had to happen before you say, enable this thing in production. When you do that is, let's say there was a new constraint you need to add or you need to ensure it works fine. Like, is alerting a part of that process that you work on, or is it a separate team that takes care of that?
Yeah, it'd be interesting to see how other companies do this as well. But so for Stripe, the way it would work is, I think it depends at which level of alerting. So if something is happening to the features where maybe the features aren't being populated or something and it's like an infra failure, then we would usually not design that alerting system or carry the pager for it. If it's something around like maybe model throughput, that seems infra related as well. But if it's something around the ways that the model itself is producing predictions, then that is something that our team owns. And I think that kind of makes sense because it's something that's extremely tied to the product, right? Like, really, the product team can tell you, because I guess we're not only you don't only alert on anomalies, you alert on undesirable behavior. Kind of like going beyond like, oh, is the model performing well or not? You could say like, well, we expect that this model would like catch this many fraudsters a day, and we've seen that like it's much lower, and so like we kind of know what that limit is, whereas like an infra team might not. And so while there's kind of room to provide maybe services so that team can like construct these alerts easily, which at Stripe we're lucky enough to have so like on an infra level, I think kind of makes sense that for the like, is your model really doing something crazy? It should be on the product team because that is just a different definition for each product team, right?
Mm-hmm. Yeah. That makes sense. In terms of like just team structure, who are the partner teams that you work with most frequently? Like you mentioned, product is one aspect. I would imagine infra team would be another. But like, can you tell us more about how the team is structured?
Yeah. So yeah, obviously close collaboration with products. I mean, I wasn't even thinking of it as a different team. So like a product team with some embedded ML folks on it, but in some ways it can be thought of as a separate team as well. But yeah, very close collaboration with product. Then other than just then collaborating, I think like similar to other engineers, you have sort of like just foundation teams that can like manage servers, infrastructure, developer tools. That's I guess much less of a collaboration and more like we're really thankful for their services and we use them to save so much time. We collaborate with platform machine learning teams, or machine learning platform teams, I should say. And they're kind of two aspects to that, which is serving models. And we have some blog posts around sort of, our model training and serving framework, where like many companies, we have sort of like an in-house way to define a model, train it, and then deploy it and be kind of confident that that model is idempotent and immutable and will kind of do the same thing online that it did when you train it offline. And then there's a feature computation side of it where we collaborate closely with that team that kind of produces systems that help us define features that again will be the same offline and online that won't, where we won't have some like time traveling where we're seeing data from the future when we're training models. And they also own the feature store aspect of it, where we get features very quickly during transactions.
I see. That makes sense. One thing which you mentioned, it kind of reminded me of something we were discussing before we started recording, which was versioning of the models, or rather the code itself that trained the model. Like if I'm thinking about, again, regular software development lifecycle, there comes a point where you decide to deprecate a system because it has served its purpose, and you're like, yeah, we got to build a new one. Does that ever happen with ML models where you say, oh, this thing has been running really well for the last X number of years, and now it's time to replace it? And if so, well, like you said, in some cases, either you don't have the code that trained that model or the data that trained that model. So like, how do you think about that?
Yeah. I mean, ML is crazy for that reason. Again, like for more context, yeah, I guess like what we're talking about is it's very possible, if you have a good model hosting service that like all you need is like you train the model and then, you serialized it, and then the model serving service just takes care of it, and it can take in requests for pretty much forever. And so if you've done that 4 years ago, and your training code base has changed, and like you trained it on a version of scikit-learn that's deprecated, and like maybe it doesn't even work on your current infrastructure, like you can still have this model that works well, and know that it's impossible for you to retrain it. And as much as possible, I think Stripe tries pretty hard for that never to happen. And so like when you train a model, the idea is that as part of that, you want to serialize and keep like, what's the data set, both train and test, what are all of the features, what's the version, like the Git hash that you trained it on. And so at least, maybe there could still be factors that could make you unable to retrain that model, but like at least you can reconstruct almost exactly what it was. But I think it's a hard pattern to get right. And I'll say this, I think the main failure mode is that if I'm an ML engineer and I'm on a project, and let's say I'm building this new model for this new use case, it's never been done before. I build my model, it's good, I ship it, and I move on to something else. And it's possible that like retraining this model every month would like be very valuable, or maybe every year. But it's like, I'm not going to do it. It's like I don't have other things to do, or like usually it'll just fall below the cut line of the projects that most people have. And so most models don't have that baked in. And so, it's obviously like an opportunity at the infra level where you could say like, okay, well, maybe it's something that we could kind of set up where if a model is too old, we have to say like, hey, we need to retrain it because we're afraid that we're going to like lose the ability to do so. But then you go back to what we were talking about, which is it's not trivial to automate. It's like you retrain it and then you block all of friends again. And then if there's not an engineer to look at it, like you're going to auto ship it and that's going to be terrible. And so I don't know. I honestly think that's why this world is fascinating to me, is it feels like we just don't have almost the right vocabulary for it yet. Like we are, kind of mad scientists that create these like magic black boxes that really do good things for us. And we're like, oh, this black box, it's great. Let's like put it on a server and keep it there. And hopefully it keeps being kind to us over the years. And like, I think there's like some aspect of seeing like, not only like, model lineage and like model development, but kind of like almost like the tree of life for models. So like how you evolve like one model to the next, which is just not, I don't know. I haven't read anything great about it. I think every team is kind of figuring it out for itself. It's fascinating and challenging.
Yeah, on one hand, I feel like it's just a matter of time for, this whole CI/CD thing, right, to maybe kind of permeate to other areas like ML. But on the other hand, exactly what you were talking about, where having to have product to take a look whenever you want to deploy something when you do block half of France, like we're coming up with those criteria. I feel like it is a lot trickier to automate, even if your tooling keeps on getting better. But yeah, I guess we'll see.
Yeah. I mean, the other interesting part is that when something is working well, we don't tend to look at it. At least I don't, because when something's working, it's like, yeah, don't touch it. It's doing its thing, and unintentionally we kind of abandon. I mean, it's a strong word, but yeah, we kind of abandon that specific, in this case, model, or in other cases, software in general.
Yeah. Oh, that's a really good point. In fact, if you think about it, you have asymmetrical outcomes, right? Where it's like you have this model
Hmm.
and you could retrain it and maybe it'd be like 0.5% better. And maybe that's great. Maybe that's $1 million a year. But there's also like a 1% chance that you break everything. And, is that really worth it? And at least like, even if it's not at the company level, to you as like the person that's going to do it, are you going to make that decision of taking that gamble? Most people are pretty risk averse. And so they'll say like, to your point, yeah, like, it's working well enough. We don't need that extra $1 million.
Yeah, yeah. Well, we're getting towards the end of the conversation, and I would do this podcast a disservice if we didn't mention that you wrote a successful book, building machine learning powered applications. Can you? We'll link it in our show notes, and we highly recommend our listeners go check out the book. Can you tell our listeners a little bit about what the book is and like what kind of audience it would be most relevant to at this point?
Yeah. Oh, thanks so much. Yeah, I'll just do a 25-minute overview, if that's okay.
Go for it.
Perfect.
No, I think it talks a lot about what we've talked about here. I think specifically it talks a lot about that first part, which is, how, like, from my experience as a data scientist and leading projects at Insight, I've seen a lot of sort of like good and bad ways to quickly build an ML project for a product application. So it's really for that like 0 to 1. You have a product idea. Maybe you have some experience with ML. Maybe you don't. You have some. It requires a little bit of Python experience, or at least there's some Python code to read. And you want to kind of bridge that gap between like product idea or just like having done some data science on the side and kind of making it useful. And the goal is to focus more on the process of machine learning and less about the theory of it. There's a lot of excellent books about like the theory or how you use the frameworks. And I went to write one that was about that experimental mindset of like, so, you want to ship an ML product. What do you do next? And so, yeah, that was the goal of the book. And so far, from the feedback I've gotten, that seems to be the target demographic that really benefits from it the most. So if that's, something that resonates with anyone, I would suggest it. There's also, I should say, a free chapter available online that maybe I could send to you, and you can add it to the show notes for people that want to check it out.
Yeah, for sure. What would be a good website for people to go check out this book?
Oh, if you just go to mlpowered.com, you will have that book. That's machine learning ML powered.com, and if you go to that/book, that's where the free chapter is.
Awesome. We'll certainly link that in our show notes, and we highly encourage our listeners to check it out. I have a slightly different question about the book. I'm actually a lot more curious about the process that you kind of went through to write the book itself. And what I mean by that is there might be some engineers out there who have some ideas or want to put out a book. Like, how does one start? In this case, O'Reilly is the publisher of the book. Like for people who want to either find a publisher or just think about like, hey, I have this idea. Should this be a book? And if it should be, what do I do next? Can you talk a little bit about what that process looked like for you?
Oh, talk about a short, 1 minute answer here that I can give you. Okay. So just to summarize, the questions were, how should you know if you can write a book? How would you go about writing a book? How would you know if it's a useful book to write? Is that right?
Yes. Yeah.
Easy peasy. So I will say that O'Reilly is a great publisher, and they have so maybe the like simplest answer is they have a kind of like a submission template that if you want to write a book, you can send them a template or fill it out and tell them I want to write a book about this, and it has 3 or 4 pages of really good questions that you definitely should ask yourself before you write a book. Like, who's my audience? Like, why don't they know about this? Is there another book? Are there no resources? If there are no resources, is it because no one's interested in it? Kind of like what, just kind of market sizing, but also like, why are you the right person to talk about this? So I think that's a great process, even if you don't end up submitting it, to just kind of working through it yourself. The other thing I'll say is, for me, the way I got started is I started by writing blog posts, and I recommend that to anyone that wants to write a book, because writing a book is a lot of work. It takes a very long time. People warned me that it would take a long time, and it took much longer than I thought it would. Whereas writing a blog post is already hard, actually, but sort of like could tell you, like, first, do you like this? If you hate writing a blog post, writing a book might not be for you. But also, it can help you gauge your audience size. And I guess that's the last point for me, which is I started by writing blog posts because I developed strong opinions about machine learning from doing all these projects. And after a few blog posts, I wrote a blog post that was extremely popular that was around sort of like how to do NLP projects. I think that blog post now has like 500,000 reads. And that particular blog post was the reason that O'Reilly reached out, because they were like, oh, you like to write, you're okay at it, and you have an audience. So it's probably a good idea for you to write a book. And so I think that's why it's kind of like a natural thing to do. Like, try that for a while, see if you like it. And if you do, go forth with the book.
Oh, that's great advice. Thanks for sharing that. And I know we're getting towards the end, and there is one question which we ask almost everyone on the show. What was the last tool you discovered and really liked?
What's really tragic is that I remember listening to the most recent episode of your podcast, hearing this question and saying, I should think of a great answer for this. And then I forgot about it.
Got you now, Manu.
Oh, man. The last tool. I'm going to cheat because it's not the last tool I used, but it did come back up recently. It's something I'd use, actually. It's actually used in the book, but I hadn't thought about it for a while, and it came up at work because it happened to be something that would really help. Great Expectations is a library that essentially tries to make tests for machine learning models, which is not an easy thing to do because, again, like, it's not clear how you test them. But I truly think that that's sort of like one of the promising areas going forward. And the reason I really liked it is that it forces you to, like, you build your machine learning model, and it's kind of like, test-driven development advocates would say, it forces you to kind of maybe be a little bit more thoughtful. You're like, wait a minute, like, what do I actually want to guarantee? Like, to give you an example, if it's a fraud, a system that catches fraud, it's like, what's an example of a transaction that's not fraud? Like, how do you write that of like, here's an example of this transaction. This transaction is a flawless transaction, no fraud, and like, kind of like working through that process is both really useful and really productive. So for anyone that's thinking of doing it in machine learning or does it already, Great Expectations. It's an awesome library.
Yeah. Well, you shared a lot in this conversation. Is there anything else you would like to share with our listeners?
Yes, my deepest thanks and appreciation. This was awesome. Thanks for hosting this podcast. It's so fun.
Oh, yeah. Thank you so much for taking the time. Like, this was awesome. I have learned a lot talking to you on this show, and I'm sure many of our listeners will as well. Thank you so much for coming on the show, Manu. Really appreciate it.
My pleasure.
Thanks, Manu.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.